Bluetooth device is connected successfully.
Oh my God. Hello, welcome back to my YT channel. So, at this moment in time, I will be able to present one basic problem for quantum mechanics. Okay, so this is it. What is the angle of inclination of a scattered photon with an amplitude of 1 times 10 to the negative 4 meters and a final wave, oh my God, and a final wavelength of 1 times 10 raised to the power negative 10 meters? The initial wavelength of the incident photon, wow, before it's scattered is 1 times 10 to the negative 8 meter. Oh my gosh. Incident photon meaning it is from rest and then it will move to another point, something like that, right? And then, so it's gonna be like there's an electron. Oh my gosh. Okay, there's an electron, and then there is a photon, of course, a light particle, and then this one, a light particle, just like this, a fluorescent will emit light rays, right? In those light rays, there will be equivalent photon electrons, or shall we say photon particles that is quantized. Quantization of energy. Okay, so what do you mean by quantization of energy? There will be a sort of combination of two energies, the energies from the electron and the photon, like that. And then since we know that the lights are scattering, right? So there must be an energy going to each other, and there's also an energies going away from each other. So the energies that are going to each other, this will be quantized, meaning there will be what do you call this one? Equilibrium, okay, or equalization or combination. So, right? So, okay. I need to get the 10 for this. Okay. So, we write the given first, of course. The given is most of the quantum mechanics problems are experimental in nature, so we have to illustrate by means of a drawing or any symbols or any representation or any graphs, the behavior and the motion of this subatomic particles or the interaction, right? Okay, being considered, and it is the particle that it is considering the matter. Okay, because matter involves three phases, right? The solid, the liquid, and the gas, and this is a solid. Okay, something like that, and then it will become a light particle, which is a photon, meaning it's just kind of a gaseous state, right? Okay, like particles, okay, something like that. So it's in here, we need to understand really what is a photon. Okay, so the photon is the light particles, okay, that carries electromagnetic forces that holds together the electrons in an atom, something like that. Okay, so it's very clear. Okay, electromagnetic forces. Electro meaning we will understand the electric field, okay, forces, and then magnetic field in the magnet, meaning there's metal, meaning the interaction of a photo electric effect, okay, something like that, to the law of magnetism from the metals, okay, something like that. Of course, it should there will be no scattering if there's no something like that. Okay, so given in data. Okay, amplitude represented as h. No, not h. It could be another symbol. here, right? Another symbol of, let's say, X, something like that, amplitude. We can represent any symbol lang siya, okay? Because the H is the Planck constant. So if we let this as an H as a vertical height, then it will confuse also. Okay, let's just let X as an amplitude. Okay, X is equals to 1 times 10 to the negative 4 meter. This is amplitude. The vertical height or the vertical distance when the photon particle travels from point A to point C to point D initially and finally, or initial or final. The final it travels to the final state, meaning there's there it will be scattering already. Electrons will go on the other side. Okay? Because the photons and electrons will always meet with each other magud siya. Okay, something like that. So it should always paired with electrons. It's impossible that energy will be quantized if there will be no electrons in the combination, something like that. Okay, so this is amplitude. Okay, my goodness, amplitude. Uy, nahurot na akong pintil-pino eh. Char. Ganon. Amplitude. Oh wow, green. So that we can understand the amplitude, we will draw a little bit a wave function. Okay, something like that. Okay. So this topic really, guys, is very important for communication. Okay, there's a sound waves like that, and the light also. Light waves and sound waves, very important for communication under quantum optics. Still quantum, meaning subatomic particles. So without this topic also, we don't have communication we have now. Okay, it's that in this theory that we need to understand the quantum mechanics of those sound energy, something like that, or light energy. Okay, so cell phones, mobile phones, laptops, shall we say, tower, signal tower of any TV networks, something like that. So that we can have the video call every day, we can chat to our friends. So the principles behind that is through quantum mechanics. Okay? And another also application is for the laser in hospitals, in producing x-rays like that in the chest. Okay? During physical tests, so it's also involved there. Okay, there's light particles will pass through your respiratory system and will detect if your lungs have no spots or have. So it is here also the topic being involved. That's quantum mechanics. Okay, branch of physical chemistry, because that's light will pass through the back chest, and then it goes to the respiratory system. It will determine if our lungs are okay, if there are many holes, something like that. Okay, X-rays and then on the gamma rays. Okay, something like that. And then that's the laser. Okay, light, of course, light, and light there's a photon particles in it. Light amplification. So amplification meaning the word amplitude is being discussed there. That's why. So 1 times 10 negative 4 meter amplitude. Amplification meaning it's a process. And then the noun is amplitude. Again, sir, light amplification. What word there is amplitude, remember? Okay. S stands for simulation. You simulate the photon particles that will pass through our chest and then go to the respiratory, and then emission, the emission of the particles or the light of particles. Okay, then radiation. Okay, because this is a process of radiation. We need to say electromagnetic radiation is a process of laser. Okay, so electromagnetism is present here for this. Okay, so that's very clear. Okay, ambition. So laser is the application for this, huh? And then another given here. Okay, in hospitals. Okay, to for the cataracts or whatever. Okay, inside our digestive system, okay, cardiovascular system, respiratory system. But the cost of the operation is very expensive because the technology is very expensive also. Okay, so meaning to say those technologies are having the concept during the engineering design stage of those laser technology equipment found in different hospitals all over the world. Something like that. Okay, so our final wavelength. Lambda, like this lambda. You remember that one in engineering subjects before in physics, right? Lambda like this. And then theta in trigonometry. Theta is also a circle, but there's another line, vertical line in between, in the center, that's phi. Angles of inclinations for that. And that's the time we will apply the Pythagoras theorem, okay, of right triangle in trigonometry. It's also applied here in quantum mechanics, the basics of that. Okay, because normally this light scattering will also develop an angle of inclination like a triangle. Okay, a right triangle, something like that. Okay, so final wavelength lambda f is equal to 1 times 10 to the negative 10 meter. And we are very, very lucky because I told you in my previous vlogs and live streams that we need to memorize the Planck constant small h because it will be incorporated in our equation, formula to solve for the angle of inclination of the scattered photon. Okay, so meaning light particle. The light particles are scattering, then we need to determine the angle of inclination. That's our problem here in this. Okay, like the particles. Okay, and now our initial wavelength. Chararat. Okay, initial wavelength of our photon is 1 times 10 to the negative 8 meter. Okay? Hala! And then, if this is a photon, meaning coming from the light, that's where light particles, of course, and the energies are quantized in a discrete particles known as quanta. Charot. Okay. If the question will say, what is quanta? Discrete particles of the energy being quantized. So, Sir Sotero, what is quantized? What do you mean by that? We need to remember the Bohr model theory regarding the, electrons in the outermost shell. Remember? Principal quantum number n is equals to 1 in the first energy level. N is equals to 2 in the second energy level. And then, if the electron excite will go to the N to excite meaning move or transfer because he received the energy of the photon. Okay? If there's no energy of the photon, he will not escape to the other orbital. So during the escaping of the electron to another orbital like that, and then if it is still on the original level that is ground state, and then when the contact between the electrons and the photon energies, so that is called quantization. Both energies are quantized, and that is absorption state. Okay, just like a chemical reaction, they will react with each other. But in here, this is called absorption state. After the absorption state, then they will excite together. After the we will go to the n is equals to 2, n is equals to 3, 30, and then like that. So the energy will increase upon quantization. Okay, that we mean by quantized. Okay, like that. So very clear, right? There's a movement, a velocity, a motion going to another level. The level is what we call energy level or the principal quantum number. Okay. in our chemistry. It's related to here also. Okay? Now, what is the okay angle of inclination? So we need to get the theta. Uy, theta kaayo. So in our trigonometry, how can we determine the cosine theta? Chot, theta. Lagi ang Jud. Okay. Okay, gamit mo kayo sa mga engineers ang mga ano, cosine theta, tangent theta, okay, sine theta, o hypotenuse, the base, okay, the height, ganun, ganun siya, okay, ganun. Are stated in the problem. The Planck's Law, discovered by Max Planck, because we have Planck constant h by which is equal to 6.67 times 10 to the negative 38 joules second. Ganon. H. Moong ni pangita ko laing letter kay ang H man good Planck constant, and then in our usual symbol declaration in physics and chemistry, H is just a height, a vertical height, small h. So it will be confused to us. So I let x as an amplitude wavelength in a wave function. None. Could either be a sound wave or a light wave. Okay, so h is equals to 6.67. Guys, I tell you honestly, this topic, I don't have really comprehensive knowledge when I was in college. Okay, I just reviewed because a lot of this also mixed with chemistry lecture. That's why, as we go along the way reading it, okay, we can understand something like that, the pattern, especially if you know the behavior of electrons, protons, and neutrons, then you can easily understand, okay? So though it's a little bit complicated, somewhere along on the equations, okay? Because these are light particles with an exponent of negative in which we cannot see by our naked eye. Okay? Even the microscope cannot see this. Okay, only the laser technology can see this, or atomic spectra. Atomic spectra, or what we mean spectroscopy process. Spectroscopy by having the photometer, because that was we have photon, so it can detect by the spectroscopy method, having the photometer as a part of this, spectrophotometer or nasapin ang dila. Okay, that's why we have spectrography. Okay, so this is about atomic spectra or spectrum. Spectrum meaning a band of wavelength of, particles travels in a certain wavelength. That's why we have color, right? That's a band of wavelength of the particles through its frequency. Okay, it's being repeated over and over again. It's being repeated and it's being a cycle, a visible color that we see for the light. For example, the green, the red, the blue, you remember the Roig-Beeve principle, the red, orange, yellow, blue, indigo, and violet are the correct arrangement of the color of the rainbow. Roig-Beeve. Okay, so it should not be interchanged. Again, red, orange, yellow, blue, indigo, and violet. That's Roig-Beeve. So that's a band of spectrum of particles. Okay, so like that. Okay, I think it is expressed in hertz. The frequency, hertz, H-E-R-T-Z, hertz, meaning to say cycle per second, wave per second, period per second. But in here we are using waves, that's why wave per second, because we're dealing with wavelength here, or light wave specifically as a wave function. Okay? Something like that. So, trivia talaga. Actually, this is not a trivia, it's already a discovery. So, if you see a color red, you know red, so it has 735 trillion hertz of the spectrum. Okay, and then if you see, okay, if you see violet, that is 735, okay, trillion hertz. 435 red. So, meaning to say, the violet has more frequency hertz compared to the red. Okay, for the hertz, waves per second, something like that. Okay, I don't know with the other, the green, the blue, the white. Okay, that's only two. So only two I memorized. The red and the violet at least. Okay, something like that. Okay, now, then we have now what is being asked. Illustrate. Okay. So we know that in quantum mechanics there's a lot of wave function. Do you remember class the quantum superposition? Okay, the quantum entanglement, the quantum tunneling, the Heisenberg theory of uncertainty, the double slit experiment to have the wave particle duality. Okay, and now we will use the other wave function known as the confront scattering. Experimental man siya guys. Compton, okay, scattering, Compton scattering. If we have the, what do you call this one? Light scattering for the smoke detector, right? We have also here, okay, light. Okay, the scattering of the light, because smoke detector will detect, okay, it sends the smoke and it will light, and then after sensing it, okay, the smoke particles, then it will detect that there is a fire, something like that. So the smoke detector, so it's gonna be like the principle also. Okay, that this is a scattering, light scattering, or what we call as the Compton scattering. Wow. Compton scattering. Okay, Compton scattering experiment. Charot. Grabe. Okay. Scattering. Okay. Like this. Oh my gosh. Compton scattering. It's just like a tinai sa manok. Like that. When ato na siya i-barbecue, there's like a spiral like this, like this. The spiral will create just like a wave. Okay, and a distance from first spiral to the second spiral, or that's called a wavelength. Okay, something like, and when it moves, the particles going up, going down, going up, going down, it develops a momentum and the position. Okay, particle momentum and particle position, something like that, in a wave function of a light particle, something like that. Okay, so I have here, of course, the stationary photon, kay photon man jud good basta light, ha, automatic jud siya. Okay, if the question in examination in the future will say, what is the light particle emitted from the fluorescent? Question number one, for example, in examination, what is the light particle emitted in the fluorescent bulb? A, electron. B, positron. C, quark. D, fermion. E, photon. Your answer will be photon. It's very easy to detect also because the root word is photo. Okay, sometimes you'll never memorize. You just think logically that the root word is photo, then the more closer is the photon. Okay, so that's gonna be like that in choices in the examination. Okay, from A to E, and sometimes there's a none of the above on the question. Okay, something like that. So you should remember that clues through its terminology and terms alone, without memorization and without remembering the terms. Okay, so that's a clue also. It will help also a lot, huh? Okay, so we have now the incident photo like this. And first, of course, we will draw an imaginary horizontal line, something like this. Okay? So, kung ato yung ginisayon, kani si photon, nangita ni siya uyab. Okay, si photon nangita siya uyab. Nya, wa jud siya nakitang laing uyab kay nga si proton o si neutron di jud musugot niya. Okay? So ang daon ni nabili niya iyang uyabon ang electron. So gusto jud siya makigjowa sa electron. And now electron ang iyang ijowa. Okay, so photon like this. This is the photon. Okay, ganun. Tadadadat. Murag tinaiya, no? Like this. Okay. Ganon. Now, this is the incident photon here. Photon here. In this, si photon here, ni travels photon